For the next part of our unit on factoring, we're going to be factoring trinomials in the form ax squared plus bx plus c. So your essential question is, how is factoring trinomials in the form ax squared plus bx plus c different from factoring trinomials with a leading coefficient of 1? Now some of you might be kind of confused by what that means, but we're going to break that down here on the next slide. So when I am factoring trinomials in the form ax squared plus bx plus c, all that means is that I have numbers in the place of a, b, and c. So if I look at an example of this trinomial right here is an example of that. There's a number for a number for b, and a number for c. Now this is different than how we factored trinomials with a leading coefficient of 1, because normally we just had x squared plus bx plus c, where the number in front of x was always a 1. So now we have a number in front of x squared that is not a 1, and so we have to use a different method to factor. Now the method that we use for factoring trinomials in this form is called the AC method. And the reason why it's called the AC method is because we are going to multiply a times c to start our factoring. Now first and foremost, when I'm factoring, I always check to see if there is a greatest common factor. So that's your first step. Anytime you're factoring, you always do this step first. So if I look at my trinomial though, I do not have a greatest common factor, so I can skip that. The next step is to multiply a by c. So in this case, a is 5 and c is 2. So I'm going to multiply 5 times 2, and I'll get 10. Then we're going to find factors of a times c that add to be the middle term, just like we would do before. So now after we multiply a by c, we get 10, and we need to find factors of 10 that when I add them together, they're going to equal 7, because that's my middle term. So let's see, my factors of 10 could be 10 and 1, or 2 and 5. And if I add 2 plus 5, then I get 7. So those would be my factors. Now, what I'm going to do is something a little bit different. I can't just write my factors like I did before, because if I tried to do that, if I tried to write x plus 2 times x plus 5 as my factors, when I redistribute this, x times x does not equal 5x squared. So that does not work. So then what I need to do instead is rewrite the whole expression, and this time I'm going to replace the factors that I found for my middle term. So I'm going to break this 7x down into 2x and 5x, which is what I got as my factors. So I'm rewriting the whole thing, 5x squared plus 2x plus 5x, that replaces the 7x, plus 2. So I just rewrote the whole thing, replaced the middle with the two factors that I found. Now what I can do is I have a 4-part polynomial. And how do we factor 4-part polynomials? We have to use a special method, which is factoring by grouping. So I'm going to group my terms into binomials, and then I'm going to take out the greatest common factor from each group. So step 5 is to factor by grouping. So if I take out the greatest common factor of this group, I would take out an x, and I would have left over 5x plus 2. Then, if I look at my second group, the only factor that I can take out is a 1. So I'm going to take out a positive 1, and so I'll still have left over 5x plus 2. So then if I look at my factors, this group and this group both have 5x plus 2. So if I use that as my greatest common factor, and I take out a 5x plus 2, Then I have left over x plus 1. And if I double distribute this, I should end up with what I started with, 5x squared plus 7x plus 2. So let's just check that really quick to make sure that that works. So I'm going to take 5x times x, which would be 5x squared, and then 5x times 1, which is positive 5x. Then I have 2 times x, which is positive 2x, and 2 times 1, which is positive 2. So if you look at this, right now, this is basically the same thing that I had right here. I just had the 2 and the 5 switched around. And so that's basically the same thing. That is why the AC method works. And then, of course, I could combine my like terms. So I would get 5x squared plus 7x plus 2. And so you can see that when I check, I get the same thing that I started with. So let's try one more example. Oh, and the last step, of course, is to write your factors. So our answers would be 5x plus 2 and x plus 1. That would be your final answer. Now let's try one more example just for practice of factoring using the AC method. So go ahead and pause the video if you want to, and go ahead and try this one on your own. Now remember, the first step, if we go back through our steps, the very first step whenever you're factoring, always, 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 is to check for a greatest common factor. Now, let's say that I forgot to do this step. And I'm just going to go right on ahead with what I normally would do with the AC method. And I'm going to forget that I'm supposed to take out the greatest common factor. Oops. So, if I was to just go ahead and start, this number would be A, and this number would be C. So, because I'm using the AC method, I would multiply A by C, and I would get 24. And then, of course, I need to find factors of 24 that add to be negative 14. So, what numbers can I multiply to get positive 24 that add to be a negative 14? That's kind of tricky. So, let's say I took 24 and 1, that wouldn't work. 2 and 12. Now, that would add to be positive 14. So, in order to make them be negative, I would have to do negative 2 and negative 12. So, a negative times a negative equals a positive, and then they add to be a negative number. So those are my factors. So I'm going to now rewrite the expression using the factors that I found to replace my negative 14x in the middle. So I would have 4x squared minus 2x minus 12x plus 6. Now I have a 4-part polynomial. All I did was I replaced the negative 14x with these two numbers right here, negative 2x and negative 12x. So now because I have a 4-part polynomial, I have to factor it by grouping. So I'm going to group these two together and group these two together. So what would be the greatest common factor of the first group? Well, I can take out a 2, and I can also take out an x. And then if I divide that out, 4 divided by 2 is 2, and x squared divided by x would just be 1x left over. Then negative 2x divided by 2x would be minus 1. Now, if I look at my second group, I can divide these by 6. But if I pay close attention, I have to come up with 2x minus 1 as my leftovers. And so what I'll probably want to do is take out a negative 6. So if I take out a negative 6, then I would get positive 2x minus 1. And so now you can see that these are going to be the same. If you take out a positive 6, you'll get negative 2x plus 1, and so then you'll notice that you need to change or manipulate something in order to make them be the same. So from here, if I take out a 2x minus 1 from both groups, then I would have left over 2x minus 6. Now, remember how I forgot to take out my greatest common factor at the beginning? If I multiply this out, then I still technically end up with this answer. But if I wanted to factor completely, if I look at these two groups, is there a greatest common factor in this group? No. Is there a greatest common factor in this group? Yes. Out of this group, I could take out a 2. So if I took out a 2, then I would have left over x minus 3. And then I can go ahead and leave my 2x minus 1 there. So if something happens and you forget to take out the greatest common factor at the beginning, then you can double check at the end and see if there's a greatest common factor in one of these. And because there was, I went ahead and took out that 2. And then I had this left over. So if I was to double distribute these and then multiply everything by 2, I would end up with what I started with. So if you forget to take out the greatest common factor at the beginning, it's no big deal. You just want to make sure that you take it out at the end if possible. All right, go ahead and feel free to go back to your essential question and write your summary. Thank you.